Hello everyone and welcome to PC Retro Tech. So in this week's video, these are the toys that we're going to be playing with. And as you can see, there's a bunch of socket 3 motherboards here and a whole lot of other components. And today I'm going to be answering once and for all what it is that gives really high frame rates on socket 3 motherboards. And believe me, you're going to see some really high frame rates today. So of course the star of today's video will be the AMD 5x86 with a Pentium 75 rating. It's running at 133 MHz, but of course we're going to be overclocking this. And I also have a new motherboard. It's an Opti one with a UMC chipset and a second UMC chipset board here. So we're going to try those out. I also have a lot of extra flexibility with cache and memory today, which is an experiment I wanted to try for a while. So we're going to see what difference that makes. Now the first thing that I found that's really important with these socket 3 boards is to make sure the cache is configured correctly. Of the 5 boards that I purchased, 3 have actually been completely incorrectly configured, and therefore there's been no cache in operation at all. So the first thing that can go wrong is sellers can just remove all the cache chips because they can sell them separately. So make sure the chips are actually populated. Some boards were sold originally with half of the cache chips populated. This is fine, but you want to make sure that the correct half is there, because if half have been removed, they might have taken the wrong half out. Typically there are 2 banks, and they're either left and right as we have here, or sometimes they can be interleaved. And you want to make sure that the correct bank is populated, because many of these boards require bank 1 to be populated before bank 2. So check the motherboard manual. The third thing that can go wrong is the jumpers can be set incorrectly for any number of reasons, but particularly if they've taken cache out to sell it separately. But don't stop there. Also look at the chips themselves. Look at the numbering. So here I have 256-20, which means that if I have 8 of these chips, then I have 256 kilobytes, and the -20 means 20 nanosecond, which is fine. You might also notice that there's an additional chip here. This is called the tag RAM, and most common configuration is that it's exactly the same chip as all the others, but it doesn't actually need to be. It's irrelevant. If you look in your motherboard manual, you may discover that you can get away with a lower amount of memory in that chip. Now also some boards have 32 pin slots, as this one does. Some have half 28 pin, half 32 pin, and some are just 28 pin slots. This is not important. Of course it's important which end of the slot the chips are installed. But the larger chips are typically for 512K and 1 MB configurations, and they are exceedingly rare and hard to come by. So don't worry that you don't have all of the pins. But you can't tell just by glancing at the board. You really have to count the number of pins because they may only be 28 pin slots in the first place. And that's not really important. The other thing you want to do is run the cache check utility that, for example, comes with Phil's Computer Labs benchmark suite, and it will tell you the speed of the internal CPU cache, which should be either 8 or 16 kilobytes depending on what chip you have. Then it will show you the speed of the cache up to whatever size cache you have, 128 or 256 kilobytes typically. And then it will show you the speed of main memory. And you should see the 3 distinct speeds there. The lowest number of nanoseconds should be the internal CPU cache, then the cache, and then the main memory. So the first board I want to look at today is this VIA board, and it's featured on the channel before. I've mentioned that one of the VISA local bus slots doesn't work. And there's a common problem, by the way. I've had a number of boards with that problem, but in this case it's due to a missing trace on the motherboard. It's also had some problems starting up, but once it goes, it goes. And a more serious problem actually is that it doesn't support Ide memory, so we're going to be stuck with 70 nanosecond fast page memory today. But the real reason I want to give it another crack is because I just discovered that one of the cache chips had a pin bent under instead of going into the slot, and so of course that wasn't working. So I'm going to put in the AMD 5x86 chip as well, and we're going to do some overclocking and see just how far this board can actually be pushed. So I know I did promise very high frame rates today, but I think 83.3 frames per second is a little bit unrealistic. Something's clearly gone wrong here, and I've noticed that Quake does this. Sometimes it gives very high or very low frame rates. I think that there is a stability issue. I had two 16 meg sticks of RAM in here and wasn't able to get through the benchmark. Now with a single 32 meg stick, I get this result. But I think that the issue is possibly also to do with the cache. So I have the 20 nanosecond ISSI cache RAM here, and I think either the memory or the cache is not handling the highest settings that this motherboard can throw at them. This is still with the DX4100, so we'd like to get that stable before we move on to the faster processors. So I'm going to try fiddling with different kinds of cache and different kinds of memory and see if I can get this stable. So I did manage to get that stable, and you can see that I have a much more reasonable 10.5 frames per second now. So what I did is I switched out the cache chips for the Alliance ones. I actually left the tag RAM alone, just the rest of the chips. And all the stability issues are gone. I tried it in multiple configurations with the memory, and it always gets through the Quake benchmark now. The other thing I tried is the 15 nanosecond UMC chips, and this made no difference at all. Cache check still shows 20 nanosecond for those chips, and that's not too big a surprise. Probably the board just doesn't want to run those at a higher frequency. So I'm going to try now some of the other chips and also some overclocking and see how far we can get this number to go up. So a very interesting thing with this board is that if you overclock it by setting the front side bus to 40 instead of 33, the processor will run at 120, and the benchmark for 3D Bench goes up to 71.4 from 66.6, which is what you'd expect from the Visa Local Bus running faster. But you'll notice here that the timings for the cache and memory are terrible. So we had 20 nanoseconds for the cache, and it's now 23, and we had 55 nanoseconds for the memory, and that's now 90 nanoseconds. So it looks like this board actually just slows down the cache and memory when you overclock. And as a result, the Quake benchmark doesn't change at all. It stays at 10.5 frames per second, which is pretty lousy given that we've overclocked the CPU. So after a lot of fiddling, the highest score that I got with this VIA board is 11.1 frames per second in Quake, and that was with the AMD 5x86 chip, and that was running at 160 megahertz. Of course, the real problem with this board is that it clocks the memory and the cache back when it boots up at a higher frequency. It doesn't really support these chips officially anyway. The highest score I got in the 3D Bench was 71.4 frames a second, and that was at 120 megahertz, and that was just with the Intel DX4. So a lot of the other chips didn't start up at all, or they were just detecting as DX2s and so on. So I'd say out with that board, on with the next one. So this is the Opti board, and you can see that it's old enough that it has 30 pin slots, although there's two 72 pin slots that we'll be using here. It does have 15 nanosecond cache RAM in it, and of course there are 3 Visa slots here, but there's no onboard I/O, so we're going to have to use an I/O controller, and I'll experiment with both a 16-bit and a Visa Local Bus controller and just see which is the best timing and use that. So I managed to get the Opti board all set up, and after quite a bit of fuss to try and get stability, I've got some very interesting timings here. So the internal CPU cache is 11 nanoseconds, not 10, which is a bit of a surprise. The external cache is still at 20, even though the chips are actually 15 nanosecond on this board. But the real surprise here is the memory timings are now 36 nanoseconds instead of the 55 or so that we had before. So this is certainly a big improvement over the VIA board, which seemed to add the cache time to the memory times. So I'm actually quite optimistic that this board will perform quite well. I did have a few early instability problems, and so I tried changing the cache chips out for the UMC ones, but this made absolutely no difference to the board. So I did manage to get to 13 frames a second with the Opti board. That's with a frontside bus of 40 MHz with the DX4100, the Intel chip. And I was having some earlier issues with stability. It would either hang after the 3D benchmark would run, or sometimes when the machine was booting. I haven't seen that recently, but I'm pretty sure it's still there at some point. So I did get 76.9 frames a second in the 3D bench. So far this is the best board of the lot. However, I can't get any of the AMD chips to boot at 120 MHz, and that includes the 586. So this is the SIS board. We know from a previous video that it performs quite well. The biggest problem is that it's really difficult to figure out the configuration of the jumpers on this particular board. It also doesn't support Ide memory, so we're going to be stuck with the fast page memory. It does have 3 working Visa Local Bus slots, and there's no onboard controller, so I'm going to try both a Visa Local Bus and an ISA controller, and I'll just take the highest score out of the 2. So this has 20 nanosecond cache RAM on it, which should be fine. Basically it looks like if your cache RAM is not holding you back due to timings, then it's probably fine at 20 nanosecond. So 13.8 frames per second, so that's the best that we've had so far by far. And the reason for this is that I'm able to run the AMD 5x86 chip, and unfortunately though I can only run it at 150 MHz and not 160, and the reason for that is that although I can set the frontside bus no problems, I can't set the multiplier here. So I'm stuck with a multiplier of 3. Now, of course, I've been through the jumper settings looking for something that might change the multiplier, and unfortunately it's not listed in any of the manuals I can find for this board. Even setting this up as a DX2 configuration still doesn't give me the 2 times on the board, which would give me the 4 times internally in the 5x86 chip. So I don't know why that is, and that's quite frustrating because obviously this board is performing quite well. One interesting thing about this board is that I can actually run it at 180 MHz. So it seems like it supports a frontside bus of 60 with the multiplier of 3 giving 180. Unfortunately the board posts, but it doesn't boot at that frequency, so unfortunately this chip just doesn't seem to support 180, and we're not going to be able to get any timings at that speed. So just to summarize where we're at so far, the VIA board was really hamstrung by the fact that it slows the memory down when you speed up the frequency. The Opti board is hamstrung by the fact that I can't run any AMD chips in it, even though they really should support the AMD DX4 chips. Well, they work okay at 100 MHz, but anything higher they just don't work. This board is hamstrung by the fact that I cannot run with a multiplier of 2. So far the issues are not so much the performance of the board, but the flexibility of the board that's stopping us from getting further. So this is the first of the UMC boards, and it has unfortunately 1 non-working Visa Local Bus slot, of course advertised online as 100% tested, 100% working. Yeah, not so much. We do have onboard IDE though, so it's not really going to be a major issue. And of course we can always put an ISA controller in. The good thing about this board is that it does allow me to select both the multiplier and the frontside bus speed. So I should in theory be able to get the AMD 5x86 working in this at 160 MHz. It also supports Ide RAM, so that'll be the first time that we'll be able to test that. And I'm going to try switching out the cache here. You can see I've got the Alliance chips at 20 nanoseconds, and of course I have UMC chips at 15 nanoseconds to try. So we'll see how much difference that makes to the score. So I'm very hopeful that this board will give better performance than the SIS board. So 15.8 frames per second, that is really incredible. The only thing is I'm not sure if this is repeatable. I had this board configured exactly this way last night. Unfortunately the video is now into a second day of filming, and I was only getting 14.4 frames per second last night. So I do know that the video card's been overheating a little. There were some blue artifacts on the screen, so I put a small heatsink on it to keep it a bit cooler, but that was on there last night, so I don't think that is the issue here. The Ide RAM makes less difference than I thought. It's about a little over half a frame per second in total, but that seems to be mainly due to the timings of the RAM. If I put in different Ide chips, then the timings get much worse. And I'm pretty sure that if I had fast page memory, which could use zero weight states, then I would also have very good timings with that as well. And I suspect the difference would then only be about 0.2 frames per second. So I think more important than using Ide RAM is just using good RAM. So I wasn't able to run all of the settings maxed out. There are two that the board won't boot with, and that is a CPU delay set to no delay and the local delay set to no delay. In both cases it wouldn't boot with either of those settings at minimum. But everything else is maxed out here. I did try switching out the cache memory for the 15 nanosecond UMC cache, but this made absolutely no difference. So even overclocked at 160 megahertz here with the 5x86 chip, the cache RAM seems to be more or less irrelevant. If you have good 20 nanosecond cache RAM, it seems to be just as good 15 nanosecond cache RAM. So the really good news is that 15.8 frames per second in Quake is entirely repeatable. So I even shut the machine down and rebooted a few times, and it's always 15.8. Now I don't know why that is. I haven't changed the components obviously, and the jumpers are exactly the same, and in fact the BIOS settings have to be as well, because there's no battery on this board, so overnight it loses its settings, which means that I had to write down the settings in order to restore them today. So it's really a mystery why it gave 14.4 yesterday. Anyway, I thought I'd show this 3D bench score of 90.9, which is really incredible. That's much faster than anything we've seen so far. So this is the second UMC board, and the reason that I bought a second board is because I was disappointed that one of the Visa local bus slots on the other one wasn't working. And I thought I can't have that happen to me twice, and I was lucky these both work. But when I got this board powered up for the first time, I was getting terrible scores, like 2 and 3 frames per second. And I wasn't able to get the AMD chip working initially. And eventually discovered that there are a number of problems here. So firstly, this jumper is for setting the multiplier, and in the manual it shows 3 pins, but there are only 2 here, and the other one on the other side is just hardwired, and so that means that you're limited to just 2 times and 3 times for the multiplier. This actually isn't a problem because those are the only multipliers that we need anyway. The other problem was that the turbo switch was jumpered, and I hadn't noticed that, and so it was actually turning off the cache and doing who knows what else and really slowing the board down. The other thing is the settings in the BIOS were very difficult to get right, and they're quite brutal. So if you don't have them set correctly, you just get horrendous performance out of this board. The cache was of course misconfigured, so I had to reconfigure that, and in fact I actually bought an additional 4 UMC 15 nanosecond chips here. Not that it seems to matter, the 20 nanosecond Alliance ones work just as well. So this does in the end support the AMD 5x86. It does support Ide RAM, and after really a lot of effort and fiddling around with this, I did actually manage to get the performance right up, and it was actually amazing, from going from quite a disappointing board to a very, very well performing board. So let me show you how this turned out. Well, as you can see, I got 15.9 frames per second out of this board after quite a struggle, but this turns out to be the best performing board of the lot. And that's quite a surprise given that it was so disappointing at the start. Now, I basically got all the BIOS settings cranked up to maximum here except for one, where there's one delay required. But there are a few other things that I want to try now. So on the board itself, there is an onboard IDE controller. Now on the previous UMC board, I couldn't actually switch this off and have a different controller on the board. For some reason, it seems to be hardwired that you either have IDE or you don't. So even if you have a separate card, it would actually switch that off as well. I don't know how that works, but anyway, in this board I think I have more flexibility here because the jumpers haven't been hardwired. So the other thing I want to do is that voltage regulator on the front of the board here is just hanging off. It's not making contact with anything, and so it gets insanely hot at 160 megahertz. So I want to see if I can get more stability, perhaps find a way to run this board at 180 megahertz, or, well, of course we could try to run it at 200. I'm almost certain that it won't run at that speed, but I will have a look and see if there are any interesting frontside bus speeds that are undocumented on this board. So there's a few things there that I'm going to try, and we'll see if it makes a difference. I've already tried switching the cache chips around, and this doesn't make any difference, as we saw with the other UMC board. But anyway, 15.9 is very, very close to the mythical 17, but in all cases where I've seen 17 frames per second in Quake, they've had the chip running at 200 megahertz. So it looks like this is probably as far as we're going to be able to go, but let's have a bit of a fiddle and see what we can find. Well, as you see, we've done it, folks, 16 frames a second. So this is pretty high, and it was nothing to do with the board in this case. I actually removed 3 of the jumpers on the Singlabs ET4000 card, and presumably this removes a wait state or something. So that's pretty close to the maximum that I've ever seen reported, which was 17 frames a second, but that was with 200 megahertz CPU. So I did try a number of other things. I wasn't able to find any undocumented multipliers or frontside bus speeds, but I did actually try 150 megahertz, and everything was relatively stable at that frequency, and unfortunately I only got 14.3 frames a second. It was necessary to clock the memory and the cache back too far to make it stable at that frequency. And at some point when I had changed some of the options, the hard drive stopped working, and I had a lot of trouble getting it to go again. First I thought the hard drive had died because it just said no operating system, but every time I'd go into the BIOS I had to replace the settings again for the hard drive, and it just wouldn't accept the settings that the drive is supposed to use. And it wasn't until I clocked it back to 100 megahertz, put another chip in, reset it with that chip, then put the 586 back in again, and then put the incorrect settings for the drive in, then put the correct settings for the drive in. Only after that sequence of things did I get the drive to work. Since then I've had no problems with it again, but clearly running things at 50 megahertz can cause some really bizarre issues. It was actually stable while it was running, but if you set the settings in the BIOS incorrectly, then you can have some problems. Anyway, I think this is a success and a great place to stop before anything blows up. Changing the power regulator by putting that screw in so it would make contact with the board did lower the temperature dramatically. You can actually touch that while it's running now, but this made no difference that I can see to anything. I did try both a Visa Local Bus controller and switching the one on the board off, which is possible with this board, and I also tried an ISA controller, and I got exactly the same frame rates of 15.9 before I changed the video card, and yeah, it just seems to make no difference at all. So I can't confirm that myth that you know, having an onboard controller or not can be problematic. So yeah, that's basically all we can do with this board as far as I can see. So that's it for this week, and thanks for watching. I hope you enjoyed this, and we'll see you in a later video. Bye!